So I have a pleasure today to discuss and talk how science could and actually should be used in decision making, how we should use research-based data for making decisions. Yes, this is the right one. Yes, so my question is, are there simple answers to complex challenges? So we tend to access the complex challenges very often with opinions or ideas, or sometimes even using populistic rhetorics. And why is this? So it is because there are no simple answers to complex challenges. It is also quite human to try to explain the things in a very simple way. It's much more difficult to dive deep into the questions, to dive deep into the theory, and step up from one's comfort chain. We have been discussing and mentioned today several times that we are living times in which we have great challenges, so climate change, biodiversity. We need to find new ways to make new materials and solve our future energy demands. So this time is also very challenging for the policymakers, decision makers, but the good news is that these are actually the topics on which majority of the researchers are working today. So data, a lot of data is available. As many different groups are lobbying for their own interest, we are also seeing and witnessing more polarized discussion. So complex topics are simplified for the sake of politics also, and there is a temptation to produce simple answers to very, very complex questions. Here I refer to a recent publication in a science journal. So this is about scenario work towards zero plastic pollution. So it emphasizes that multiple efforts are actually required to move towards zero plastics pollution scenario. So we need to have 30% of the problem can be covered by decreasing production and use of plastics, 20% by recycling, and 70% by new innovations for materials. And we have been discussing this topic already previously, and I would like to pay attention of this a bit more, because that's the area where new technology is applied, and we have lots of interesting results which could be used in order to provide totally novel materials in a sustainable way. For new innovations, for new materials, for new processes, we need to have also supportive and solid regulation. That's very clear. At its best, regulation can support innovations and also encourage for new investments. At its worst, it can be the opposite. However, regulation can also cause very opposite results, and I would like to give you a recent example of regulation which was made with good intentions, but the outcome turned out to be not so good for new innovations and also investments. And now here I refer to the SUP directive, so single-use plastics directive. So is this plastic? So isn't this a irrelative question. So everybody can see that this is not plastic, so it's a fried egg. But unfortunately, according to the soup directive, so this fried egg is classified as plastics. You say this is ridiculous, I say it too, but according to the directive, so all chemically modified natural polymers are considered as plastics. We know that eggs, they contain proteins, which are natural polymers, and once you heat the egg, so you solidify it, you change the three-dimensional structure of the egg and the protein, and you make slight modifications to the chemistry, and that makes the fried eggs classified as plastics. We understand the fried egg is as natural, as safe, and as decomposable as the natural one, but according to the classification, it is plastics. And the sad thing is that the directive is already here, and we can't do very much to change it. So it is not a coincidence that the 10 largest and biggest biorefineries for bioplastics are located and invested outside of Europe. And this was pointed out by Frederick van Gansberg at the EU conference, bioeconomy conference this year. And the main reason for this is uncertainty of the regulatory landscape in the EU. So are we closing doors for new innovations with the regulatory politics in Europe? I think this is very, very important question, and it can be very, very detrimental to our sustainability goals and also to our future development targets. I would like to give you a few examples of natural polymers which have been already discussed today, earlier. And the future of these natural polymers and their use in the future bioeconomy very much depends on the current and upcoming regulation. So cellulose has been mentioned very many times here today. So it's the most abundant natural polymer made by plants, so it's a structural material. The nice thing in cellulose is that it is appearing in various different forms, and it can be used in various different applications to replace, for instance, plastics in textiles, in packaging. And also cellulose with the modern chemistries, so we can modify cellulose in different ways to introduce new chemistries, to introduce new properties, also intelligence in some ways. But once we start to modify cellulose, we actually make it plastic. This garment, dyed garment, has also been mentioned here before, and actually the fabrics or the dress can be seen outside of this hall in the exhibition, so please take a look. But here, with the present chemistries, innovations in the present chemistries, so it is possible to save chemicals, the dyes, and also reduce substantially the amount of effluents in the processes. So all very good aspects from environmental points of view. But the modification, again, makes these material plastics as mentioned. So the SUP directive doesn't encourage us to develop technologies that science and technology could provide us. And I think it is a little bit problematic, actually quite much problematic, that we have tools, we have means, but our regulation is restricting our ways of working. Another great material already mentioned here is lignin, the second abundant material also made by plants. So it could replace phenols in phenylaldehyde resins. and that material is available from the craft processes in large amounts. But will the regulation help or hinder this natural glue to become a mainstream? We will see that. So you may now wonder, so why lignin is biodegradable and these synthetic resins are not? So that's a very important question. So the compostability or biodegradability of the material, I think that is a very key property in these materials. So the reason why lignin can be degraded in nature is that very amazing circular economy which is promoted and created by biology and by nature. So in nature we have specific microorganisms, fungi and bacteria, so they have a system, enzymatic system with which they can cut down these polymeric components into smaller units and uptake them for their growth. And that's the first step in the circular economy of carbon, which finally ends to the higher animals. So it's extremely advanced, much more advanced as compared to any of our circular economy systems which we are currently planning. It's also very important to ask whether the bio-based products are better in certain applications, material applications, as compared to their synthetic counterparts. I think Monika Österberg asked the same question today. I think there is a very clear advantage with these natural polymers if they are compostable, if they are biodegradable, because with that type of material we will never end to the problems like with what we can see with plastics in the oceans or microplastics problems which we are facing at the moment. So that is extremely important property. So how can we avoid eggs becoming plastics? With the soap directive, it looks like it was a simple mistake, unfortunately. It is basically a mismatched caused between the diversity and complexity of the polymers, different types of polymers, and the desire to regulate them in a very simple way. In my opinion, the materials, they should be regulated based on their properties, like safe, like biodegradability, and also the overall sustainability. When addressing complex questions and challenges, the scientific approach and research-based approach is the only approach that can provide us unbiased and critical perspective needed. As a scientist, we really ask the decision makers to not close the doors for science and new technologies, because we really need them in our sustainable future. Science and policy making, can we work together and how can we benefit from each other? I think we need to have relationships, contacts, and that's the main reason why we are here today. We also need to have a continuous dialogue. So we scientists, researchers, we need to be able to explain our research, our work in such a simple way that people can understand that. But scientific evidence should be differentiated from other factors which are influencing by policy decisions such as interest, opinions or beliefs. And finally, the take-home messages here. So ask us. We are more than eager to talk about our results and our findings. Also, we really need science and research-based policy making. and the latest scientific knowledge should underpin the developing EU material regulation. Thank you for your attention.